Have you ever wondered how crucial temperature is in our daily lives? Temperature is more than just a number on a thermometer. It's a fundamental concept in the realm of physics. It's a measure of how hot or cold something is, scientifically defined as the average kinetic energy of the particles in a substance. Whether it's deciding what to wear, how comfortable we feel, or even how our food is cooked, temperature plays a pivotal role. But it goes beyond our daily routines. The grand scale of weather and climate changes, they're driven by temperature variations too. From the warmth of a sunny day to the chill of a snowy winter, temperature is the unseen force orchestrating the weather patterns we experience. It influences the ocean's currents, determines wind patterns, and even impacts wildlife behavior and plant growth. Quite fascinating, isn't it? Now let's delve into how we measure this intriguing aspect of our lives. We've all seen a thermometer, but have you ever thought about how it works? Well, if you have, you're in the right place. Thermometers are fascinating tools that help us measure temperature. They come in various types, each with their own unique thermometric properties. Let's start with the basics. A thermometer is a device that measures temperature or temperature gradient. It does this by utilizing a physical property of a working fluid that changes in a predictable way with temperature. This working fluid could be mercury, alcohol, or even a digital sensor. Moving on to the types of thermometers, we have the classic mercury and alcohol thermometers, which many of us are familiar with. These liquid in glass thermometers use the expansion and contraction of a liquid to measure temperature. When heat is added, the liquid expands and rises up the tube, and when heat is removed, it contracts and descends. Then we have digital thermometers, which use electronic sensors to measure temperature. These are becoming increasingly common due to their speed, accuracy, and the fact they're mercury-free. Next, we have infrared thermometers, which measure the infrared energy being emitted from the object's surface to determine its temperature. These are handy for measuring temperatures from a distance or of moving objects. Lastly, we have bimetallic strip thermometers that use the principle of different metals expanding at different rates. As the temperature changes, the strip bends, and this movement is used to measure the temperature. Each of these thermometers uses a different thermometric property, whether it's the expansion of liquid or the emission of infrared energy, to measure temperature. Now, you might be wondering, how does heat move from the hot end to the cold end of a conductor? Well, this happens through a process called conduction. In conduction, heat energy is transferred from molecule to molecule within a substance. For example, when one end of a metal spoon is placed in a hot cup of tea, heat energy will be conducted from the hot end of the spoon to the cooler end. That's how we measure temperature, but wait, there's more to this story. So, stick around as we delve deeper into the fascinating world of temperature measurement. Ever heard of Fahrenheit, Celsius, and Kelvin? They're not just random names, you know. Let's get into it. These are the three key temperature scales used around the world. The Fahrenheit scale, devised by Daniel Gabriel Fahrenheit, is predominantly used in the United States. In this scale, the freezing point of water is 32 degrees and the boiling point is 212 degrees. Next up, we have the Celsius scale, also known as centigrade, commonly used around the globe. Swedish astronomer Anders Celsius is the brain behind this scale. Here, water freezes at 0 degrees and boils at 100 degrees. Then comes the Kelvin scale, named after the Irish physicist and engineer Lord Kelvin. This is an absolute temperature scale, starting at absolute zero, which is the theoretical lowest temperature possible. On this scale, water freezes at 273.15 Kelvin and boils at 373.15 Kelvin. Now you might wonder how to convert temperatures from one scale to another. It's simple math, really. To convert Fahrenheit to Celsius, subtract 32 from the Fahrenheit temperature, then multiply by 5/9. To convert Celsius to Kelvin, just add 273.15. Why is the Kelvin scale so special, you ask? Well, it's used in scientific calculations because it starts at absolute zero, a point where all molecular motion stops. This eliminates negative temperatures, making calculations more straightforward. So the next time you see a weather forecast, you'll know what those numbers mean. Mercury, alcohol, and even water can all be thermometric liquids. But what makes a good one? Let's start with the basics. A thermometric liquid is a fluid used in a thermometer to measure temperature changes. It expands or contracts in response to fluctuations in temperature, and this movement can be read off on a scale to give a temperature reading. Now, what qualities make a liquid suitable for this purpose? Well, A good thermometric liquid is one that expands and contracts uniformly with changes in temperature. It should also remain liquid over a wide range of temperatures, meaning it has a high boiling point and a low freezing point. Additionally, it should be easily visible and not stick to the walls of the thermometer. So, why are mercury and alcohol commonly used as thermometric liquids, and why not water? Mercury, for starters, is excellent because it remains liquid between -39 degrees Celsius and 357 degrees Celsius, which covers most temperatures we'd want to measure. It also expands uniformly with temperature and doesn't stick to glass. However, mercury is toxic, and if a thermometer breaks, it can be a health hazard. It's also expensive and not environmentally friendly. Alcohol, on the other hand, is safer and cheaper than mercury. It's easily dyed for visibility and doesn't stick to glass. It remains liquid from -114 degrees Celsius to 78 degrees Celsius, which is a narrower range than mercury, but still covers most common temperatures. Yet alcohol evaporates easily, which can lead to inaccurate readings if not properly sealed. As for water, while it's safe and cheap, it sticks to glass, freezes and boils at temperatures we often want to measure, and doesn't expand uniformly with temperature, so it's not suitable as a thermometric liquid. Who knew there was so much science behind a simple thermometer? Have you ever noticed the marks on a thermometer? There's a reason they're there. These marks signify the fixed points of a thermometer, crucial for accurate temperature measurement. Let's dive into what these fixed points are. Primarily, we have two fixed points, the upper and lower. The lower fixed point, often marked as 0, corresponds to the freezing point of pure water at standard atmospheric pressure. This is where the liquid inside the thermometer begins to expand or contract, depending on the heat it is exposed to. Now, the upper fixed point, typically marked as 100, represents the boiling point of water under the same standard atmospheric conditions. This is the point at which water changes from liquid to gas. These points, when established, allow us to create a scale between them, serving as a reference for all other temperature measurements. And that's how we read a thermometer. Simple, right? Why does it get colder as we go higher up a mountain? Atmospheric temperature has the answers. Atmospheric temperature, simply put, is the degree of hotness or coldness present in the atmosphere. It's not the same everywhere or every time. It can change from place to place, from morning to night, and from season to season. But what causes these variations? The primary factor is the sun. The sun's rays heat the Earth's surface, which then warms the atmosphere above it. But the sun doesn't shine evenly on all parts of the Earth. It's more direct at the equator and less so at the poles, causing a difference in atmospheric temperatures. Another factor is altitude. The higher you go, the colder it gets. This is because as we ascend, the air gets thinner, and there are fewer air molecules to absorb and retain the sun's heat. That's why mountaintops are often snow-capped, even in the hottest climates. The rotation of the Earth also plays a role. As the Earth spins, different parts of the world face the sun at different times. This causes the cycle of day and night, and with it the daily rise and fall of temperature. During the day, the sun's heat warms us up, and at night, without the sun's heat, the temperature drops. These temperature changes don't just affect our wardrobe choices, they're also responsible for creating weather patterns. Warm air rises and cool air sinks, setting up a cycle of air movement or wind. This wind can carry moisture, forming clouds, and potentially precipitation. These variations in atmospheric temperature also influence our lifestyles, agriculture, wildlife, and even our moods. Extreme temperatures can pose challenges to human health and productivity. Meanwhile, they can also create breathtaking phenomena like the northern lights or the crispness of a winter morning. So, the next time you're feeling the heat or the cold, you'll know why. Stay curious and keep learning.